Good afternoon, welcome to the Red Couch live here at Electronica in Munich. My name is Michael Brunn, I'm the editor-in-chief of the E&E magazine, and during the whole trade show we are talking with important people from the electronics industry about topics that are moving the industry right now. And you can watch us live here at the trade show or via YouTube and our Facebook channel. And right now I would like to welcome Brian Buchanan, Smart Grid Segment Marketing Manager, I hope I got that right.
You did.
From Semiconductor, and we will talk about innovating the energy grid, drivers and inhibitors. Welcome, Mr. Buchanan.
Well, thank you for having us.
So, we're always talking about a new grid. What are the main differences between the old, maybe not so smart, and the new smart grid?
Okay. Well, the old grid was really an infrastructure put in place to get power from the generation source to the consumer, but it didn't have any communication. It had very little monitoring. It was just a way to transport electricity between the 2 points. What smart grid is really trying to do is it's trying to add communication and control and analysis to be able to predict the power usage for the consumers. So it's really adding communication and infrastructure so that we can better provide a service and optimize the total solution for the customers. So we've had communication protocols for quite a while, and we've been able to pass information from point to point like the internet. And so really what smart grid is trying to update our power grid that we've had for many generations and years globally.
Mm-hmm. But why do we exactly we need smart grids? Didn't the old ones just work fine? Not today in Munich, but usually. So what are the main advantages and maybe the necessities?
Yes, in many parts of the world, the grid as we know it today is getting very old and antiquated. And improvements need to be made in order for it to meet a couple things. The first thing that we're seeing is population growth in many areas, with populations rising globally. And then the second thing, as consumers of electricity, we're adding more and more loads to the grid. We have our TVs, our set-top boxes, our DVD players, but we're also adding our handsets, computers, and so even within our homes and in the industry and our businesses, we're adding loads to the grid, which is causing it to reach capacity. So what we really need is we need the smart grid so that we can build predictive models and we can understand our power usage so that utility companies can provide the power that we need when we need it. So that's really the reason why we need the smart grid moving forward.
And what is really driving the smart grid?
Well, I think the first point to make is what I've already discussed a little bit, is the population growth that we're seeing and the load that's being put on the old grid. The second thing that we're seeing is government mandates and stimulus money that's being provided to help drive this new grid and to drive the infrastructure such that the governments and utilities can provide an optimized service to their end customer. So I think those two are the main points that's driving the grid at this point, but there's some others. One is this notion of reliability and energy efficiency. So I think that most people are aware that blackouts are very, very costly from an economic perspective, but also from a convenience perspective. And there's many people that rely on electricity for life-saving devices or for convenience. And when blackouts occur, that can be very, very dangerous. So if the smart grid, when it is fully enabled, will help utility companies to be able to monitor power consumption and to avoid blackouts in certain areas. Now, also what this allows the companies to do is to improve their efficiency and improve their response time. So in many parts of the world, storms can take out electricity, or there can be parts of the grid that go down. And with smart grid, what it helps them to do is, instead of sending a technician out to the field to be able to monitor and look at what the problem is, they can use the data that's coming back through the grid to run this analysis. Now the other part is it helps, the smart grid also helps to drive efficiency across for all the stakeholders. It helps the generation plants to be able to run more optimally if they understand what the load is looking like. It helps the transmission companies and the utility companies understand their load, and it helps us as stakeholders to be able to be proactive in monitoring our electric usage to help this system. And then finally, I think the last point that is really driving this market is the fact that we all want to try to be green. We want to try to preserve the environment in which we live. And by having a smart grid, this helps us avoid building undue generation plants, by running more transmission lines, by being better stewards of what we use from an electricity perspective. So I think those are really the main drivers we're seeing in the market today.
One of the drivers you mentioned are regulatory mandates, but they are different in different regions. They are different, not in every country, but in a lot of countries. So how can this be a driver when there are so many differences in this?
That's a very good question, and the way that I look at that is, yes, we have regulatory mandates that are different in countries and even locally. But really, everybody is trying to solve the same problem, we believe. We believe what they're trying to really solve is they're trying to optimize the total solution and provide the best service and services that they can for their customers. So while how they actually go about meeting that goal may be different from country to country or from utility to utility, what they're really trying to do is to provide an optimal service for their customers that is as efficient as possible.
Another problem are standards. How can we come to solutions that work at least in most regions of the world?
Yes, I don't think that we will ever come up with a standard that works in every situation. Really the problem is every use model is different. And what works well for one application and in one area may not work well in another application. So if you're retrofitting old buildings, you may use a different technology, you may use a different standard, you may use something that's technically more advanced than you would if you were developing it in a developing country, if you're building it up from scratch. So standards have their place. I think the important thing with standards as we move forward is we have to keep in mind interoperability between standards and make sure that if we're developing a standard in one area for one application, it fits well and we can communicate across the boundary to another standard. I think that's what's going to be very important moving forward if we're going to truly have a smart grid of the future. So while it is always nice to get as many people in the room and to collect input while we're developing technologies and while we're developing communication protocols, sometimes things get split just because of the requirements that are placed during that development. So I really think that interoperability is what's going to be key to driving standards moving forward in this space.
You have mentioned advantages for the customers, for the consumers, but there will be high investments to be made for the smart grid, for smart meters, and usually it ends up that the customers have to pay for that one way or another. So where's really the advantage when you have to, when it comes to higher costs for you, and when it comes to maybe to security issues?
Okay, wonderful. Really, I think the advantage for consumers is to realize the value add that they're getting back from a smart grid solution. If we choose not to enable smart grid in the future, we're going to have massive blackouts, or we could have the potential for massive blackouts. Our power supplies would be non-reliable, or they could be non-reliable. And so really one of the values that we have from smart grid as consumers is that we can have dependable and reliable power. So that when we want the electricity, it will be available to us. I also think that it's very important to realize that as consumers, one of the values that we can have is we can start to monitor and we can control our own usage. And I think it's very important to realize that once we have the data coming from the grid, and once we can visually see within our home where we're using power and what appliances are using powers, then we can be proactive on how we want to manage that power. And I think it would be very insightful when you come home after a long day of work and every light on the house is on to know how much that's actually costing you and costing the grid. Same thing with computers. When we leave computers on, we just don't have the information right now to be proactive in this market and try to monitor it ourselves. So I think that would be a great value for consumers moving forward. I think also there's a cost savings associated with it. If we are able to manage the grid and to optimize the grid, then we get a cost savings, because we all understand that if you can run an efficient and optimized system, that it generally lowers costs moving forward.
We already have mentioned a lack of standards, probably high costs as kind of inhibitors. Are there any others that you see?
Yes, there are. There are several inhibitors. The first one is this technology is being deployed slowly. The technology has existed, or the capability for the technology has existed for quite some time, but adopting this and moving this forward has been somewhat slow. And that is really due, I think, to a couple things. One reason is these are very complex projects. We need to involve governments, we need to involve utilities, we need to involve the homeowners or the property owners themselves, so that it's very complex to roll one of these out. And also there is customer acceptance. And there is perceived concern about security, about people being able to hack into the database and to get personal and private information. So this is a concern. And then there's also perceived health concerns. So these are all very valid inhibitors that I think are slowing the adoption in this market space.
Okay, so now we have heard a lot about the problems. There must be someone to solve these problems. So what can semiconductor companies like ON Semiconductor do, help solve these problems and drive the development of smart grids and smart meters?
Okay. As semiconductor companies, I think it's very important to understand the market space and to be able to help our customers solve the problems of not only today, but of in the future. Because as smart grid is enabled, we foresee more and more technologies and services being offered. So as semiconductor companies, we need to offer services to our customers. We also need to offer robust and proven technologies that can last upwards of 20 years. So it's very important that we provide solutions to our customers that help adoption in this market.
Final question. I want to know your personal opinion. How will the smart grid develop within the next 5 to 10 years?
So the smart grid, we believe, will develop. It is developing slower than I think was originally expected. The main reasons that we think it's growing slower is if we look back at the market drivers, the main market driver was government stimulus. And due to austerity measures and macroeconomic conditions which we're seeing in the marketplace, globally, this is, we think, slowing the market. But the smart grid market will be adopted. We believe that it will be adopted in developing countries at probably a higher growth rate than in the developed countries. But it's not a matter of if smart grid's going to happen, it's just a matter of when. And we believe as the macroeconomic conditions come back, we'll see more and more funding in this area.
Thank you very much. Ladies and gentlemen, this was the Red Couch talk about innovating the energy grid, drivers and inhibitors, live from the Electronica. And I would like to thank Brian Buchanan from ON Semiconductor for joining us this afternoon. Thank you, everybody, very much for watching and listening. And if you are interested, you can find this interview and all the other interviews later on at Publish Industries' YouTube channel. Thank you very much.